Okay, we started off pumping lemma on last Thursday, last Saturday, during our replacement class. And I just, what I did was to discuss about the motivation or the reason for which we go to pumping lemma. And I also discussed the work example. The idea behind pumping lemma and then the work example. Okay. So the idea behind pumping lemma is here. So we discussed that this language is not regular. Okay. So meaning we cannot construct an NFA or a DFA for this language. Okay. So why we cannot construct an NFA or a DFA for this language 0 length and 1 length and s? Here what the language says is zeros are followed by ones, where the length of 0 and 1 are equal. That is, the number of zeros and ones are equal. Okay. And if you see, n takes a value minimum 0, maximum infinity. So meaning you can have infinite count of zeros and infinite counts of 1. Okay. So when we say we cannot construct an NFA or a DFA, we cannot construct an NFA or a DFA, whether it is non-deterministic or deterministic, if you see, they are finite state machines, finite state automata. Okay, so whether it is non-deterministic or deterministic, okay, they are finite state automata. Finite state means these bubbles are called as states. So every state is going to have some function to carry on. Okay, so when we say finite state automata, the machine is going to have finite. Finite means fixed number of states. Okay. So here, that's what I meant. I use the word unboundedness. N has no boundary here. Okay. Because N can take a maximum value infinity. Okay. So we cannot implement a language that has infinite counts of zeros and ones with a finite state machine. Simple. Okay. Another issue here is we have to count the number of zeros to produce the same number of ones. That's another issue. Okay, we can't do counting with NFA because it has limited memory. Okay, so we are saying this language is not regular because n is unbounded, meaning it is going to be infinity. It's going to take a value infinity. So we need infinite memory if you are looking at it in terms of a machine. Okay, so we are saying this language is regular basing on the unboundedness. Okay, and similarly another language we saw was 0 or 1 Canesta, where the string has equal number of zeros and ones. So here also this is unbounded, infinite. Okay, infinite. So difficult to build a machine with the finite states. Okay, so again we are reasoning. Reasoning means we are giving a reason that this language is regular because of unboundedness. We are saying this language is regular, giving the reason that this language is unboundedness. Okay, it needs unbounded memory. Now, another language we saw, set of 0 or 1 Canesta, where W string has equal number of 0, 1 and 1, 0. Here also unboundedness, but surprisingly this language is regular. Why means we can implement an NFA DFA for this. That's why I said if you want to learn NFA DFA, go and construct the NFA DFA for this. Okay? There is no learning, don't get me wrong. It's not I'm trying to be cruel, not to give you answers. If I give answers for every question, then there's no learning. Right? Yeah. So if something like the Chinese proverb, don't give me fish, teach me how to fish. Something similarly here. Right? So instead of providing you fish for every meal, I'm trying to teach you. Then I tell you, okay, go and catch. I already taught you how to fish. Same thing here. I already taught you how to solve problems. You should go and solve it. Okay, so to me, very easy to construct an NFA or a DFA for this. You're going to have same number of zeros and 0, 1 and 1, 0. If you ask me, I'll do it in 2 minutes back. You'll see the answer, oh, happy I have the answer, that's all. Why I am saying it's not going to help you in the sense 100% when I give the answer in the class, that question 100% will never be asked in the exam. Okay? Yeah, the exact question will never be asked in the exam, not in the test. Okay, so you need to learn problem solving. Okay? So now, okay, let us not waste time. So I just showed you 3 languages. 2 are not regular and 1 is regular. But all of them need unbounded memory. So my say is, what I'm trying to say here is, merely looking at unboundedness, we cannot conclude that the language is regular. Sometimes it is tricky like this. It is unbounded but is regular. There are many examples. There are 2 other examples we saw. It's also unbounded, right? It needs unbounded memory. They are not regular. This also needs unbounded memory but regular. Okay? So we cannot say a language is not regular merely only looking at unboundedness. Okay? We need a concrete proof, a mathematical proof, okay, using which for sure we can say this is not regular, this is regular. Okay? That's why we go for pumping. Okay? So what is the idea behind pumping lemma in a sense? Pumping lemma looks at a property. Okay, what property? If we take a language, we take the first language that we took 0 length n, 1 length n, where n is. There was also not a controversy. One of your classmates was kept arguing something. Without understanding the theory behind it. this language is regular, you also have unboundedness here because n can take a maximum value infinity, right? Unbounded, infinitely long, but this language is regular. Okay, so I'm going to the property of pumping lemma. So what pumping lemma looks at is, okay, if a language is regular, and the length of the string is greater than or equal to P. P is called as the pumping length. Okay, but you may find difficult to understand what is pumping length. Don't bother. You can take P as the number of states. Okay, P has the number of states. So what this means is, if the length of the string is greater than or equal to P, I'll show you what is that. The diagram for this, the NFA for this is already here. Correct, right? A, B, A. We are saying n is greater than or equal to 0. Right? If n is equal to 0, you will get AA. Correct, right? If n is equal to 1, you will get ABA. N is equal to 2, you will get ABBA. N is equal to 3, ABBBA. If n is infinity, AB infinite times A. Right? Okay. So I am going to take one example string, maybe A, BB, A. This is a valid string in this language, right? Everyone? Is this a valid string in this language? Yes, right? What is the length of this string? 4. Length of this string. There's 4 characters, right? 4. How many states do you have? 3. Now you understand? The length of the string is greater than or equal to P. P is number of states 3. My string is 4. Valid string. How many states you have? What is the length of the string? Satisfies? Valid string? Satisfies? No. Right. So what this says is, the string that you choose should be satisfying this condition. Okay? So if the string that you choose should satisfy this condition, and if the language is regular, okay, you can split the string in terms of x, y, z. Okay, you can split the string in terms of x, y, z, where the string xy length is z, where I is greater than or equal to 0, is an element of the string. Okay, if this value is satisfied, then you can split this string. For example, the string that satisfies this condition is ABA, ABBA, ABBA, etc. AA is also a valid string that is in the language, but this string does not satisfy this condition, so we have to ignore this. So the lemma says the language is regular, and if the string that is in this language is greater than or equal to number of states, then we can divide these strings in terms of x, y, z. So when you divide these strings in terms of x, y, z, the xy length is z, where I is greater than 0, is an element of w. So all these strings are element of element of the language. All these strings are element of the language, right? Element means member. All these strings are valid strings in this language. That's what we mean by member. Cat. The string cat is a member of the English language. True, right? Same thing I'm saying. Here it makes sense Here these strings does not make sense. If you ask me what does ABA means, it means nothing. Because there is no semantics to these strings, there is semantics meaning to these strings. The natural language, that's all. Okay? In this mathematical language, these strings have no meaning, that's all. Here there is meaning, there is no meaning. But all these are members of this language. You get me, right? Yeah. So now going to the property here. So the string can be divided in terms of x, y, z. When we say divide in terms of x, y, z, so how we can divide? Can I simply chop this is x, this is y, and take what I'm saying is ABA. Can I take this as x? Can I take this as y? Can I take this as z? Can I split arbitrarily any way I want and assign values as x, y, z? Cannot. You can split the string in terms of x, y, z, but you have to follow the condition. What is the condition? The length of xy should be less than or equal to p. I used n. Here since I am using p, I am using p. And length of y must be greater than 0. So you should split the string in such that you satisfy these two conditions. Okay. So once you have split satisfying these two conditions, okay. Once you have split satisfying these two conditions, okay. You pump y. Pump y means you add y one time or two times. You already taken the string as x, y, z, right? So if you say x, y, y, z, you are actually pumping y. Pumping means to add y one time. Okay? So pumping y, that is repeating or adding y one or more times, the resultant string means after pumping you get a string, right? If that string is in this language, then the language is regular. So what happens is in regular languages, if the language is regular, when you split the string in terms of x, y, z satisfying this condition, you repeat y, you pump y one or any number of times, okay, the resultant string will be still in the language. I repeat one more time. If the language is regular and you split the string that is valid in this language in terms of x, y, z, satisfying these two conditions, and if you pump y, here I have pumped y one time, okay, so because x, y, z is my original string, okay, if I add y one more time, meaning I am pumping y one time. If I say x, y, z, then I am pumping y two times because my original is x, y, z. Okay, so pumping y one or more times, okay, the resultant string will be still in this language if the language is regular. So we are taking advantage of this property in pumping number, okay, to prove that a language is not regular. If this property fails, okay, this property fails, or we can use pumping number to determine whether a language is regular or not. Because if the language is regular, then I split x, y, z following these two conditions. I pump y any number of times. The resultant string will be still in the language. Okay. So after pumping y one or more time, if the resultant string is not in the language, then it means the language is not regular. Okay. So all regular languages have this pumping property. What is the pumping property? We pump y one or more times. The resultant string will be still in the language. That's it. Okay. So this is just to recall, because I know some of you would not have attended Saturday's class, and even though the video is there in in Teams chat, you may not have looked at it. Okay. You may not have watched the video. Please watch the video. So I will also put that link, Teams link in my times later today, so that you don't need to go and search the chat on Teams. Okay. So we already discussed this example problem, and I also worked on this problem as well, taking this one, A length and B length and this language. I also solved this language. Okay, I solved this language. So Is this clear? AB length and A pumping lemma, or you want to show one more time? Maybe show one more time. So the language is here. So this language is regular. So I'm going to show you using pumping number. So I'm going to make an assumption. I'm taking the string AB length PA. Okay. Element of null means this is a member of this language. Okay. I'm making an assumption that this language is regular. Okay. So what I'm saying is the string AB length PA, right? I missed something here. Where P is greater than equal to 0 is an element of member of the given language L, where the string can be written as xy length IC, where I is greater than equal to 0 is regular. So when I say this, what I mean is I can split this string in terms of x, y, z. Okay, I can split this string in terms of x, y, z. Okay, so how to split the string in terms of x, y, z? What pumping lemma says is we have to follow this condition. Okay, so to me, the first condition is the length of the string should be greater than or equal to p. Okay, and length of xy must be less than or equal to p, and length of y must be greater than 0. Okay, so to me essentially this is these two conditions. Length of xy, because we are splitting, right? When you are splitting, we need to only look at this. Length of xy must be less than or equal to p, and length of y should be greater than 0. Where is this p? Is here. Okay. So I'm going to do like this. I'm going to say what values x can take, what value z can take. I always go to y first. Y means why. Y means length of y must be greater than 0. What this means is y cannot be empty string. Okay, y cannot be empty string. This is the lemma. Lemma means theorem. This is what the pumping theorem says. Okay. So when y cannot be equal to 0, so what is the string? So when y cannot be equal to 0, where is your y? Where is x and where is z? It only says y cannot be equal to 0, right? It doesn't say anything about x and z. So x and z can be equal to 0. Okay, can be equal to 0. Okay. So when y cannot be equal to 0, where is your? You don't forget your xy should be less than or equal to b. So where is your xy? Your xy can be less than or equal to p, right? If you say xy is here, it violates this condition. Correct, right? Yeah. I know some of you. Like that. So I can read your mind, you don't understand. Okay? I give a value. P is equal to 2. Correct, right? Everybody agree or not? If P is equal to 2, this will become A, B, B, A, right? Okay, what is the value of P? 2. What is the condition says? Length of xy must be less than or equal to P. Less than or equal to P. So at the maximum, length of xy can be equal to 2, right? So where should be xy? It should be here, right? Correct, right? The xy should be here. Only then length of xy is 2. You get me now? So we are satisfying this condition. Then y should be greater than 0. That's why we club like this. If you don't club like this, what will happen is you can take like that, or you can also take like this. I can take x, this as x, this as y, this as z. Okay, so what is the length of y here is greater than 0, but what is the length of xy? Length of xy becomes 3, you know. If length of xy is 3, then what happens here? I'm just checking whether I'm following the lemma correctly. If I take like this, okay. If you split your xy like here, it still satisfies. Correct, right? Xy is less than or equal to b. Correct. And y is definitely greater than 0. Correct, right? Because you will take this as a and y as b, and you will take this as z, right? Correct, right? Yeah. So what happens if you take it like this? Okay, you are taking like this, right? Okay, xy, and this as z. So it still satisfies. In this case, x will be equal to a, and y may not be 0. So y will take the value of b, and z will take the value of ba. So what will happen if we pump y? X, y, y, z. X is a, y is b, so b 2 times, and z is ba. So after pumping y, your resultant string is still in this language, right? I pumped y one time. What is the resultant string you get? A triple B A, because your x is A, y is B, so y one more time B, and Z is BA. Z is BA. So this is your resultant string after pumping. Is this string is in this language?
Yes.
Correct, right?
Yes.
So this is the pumping property. If the language is regular, okay, and if you split the string in this language in terms of x, y, z, satisfying this condition, and you pump y one time or any number of times. If I pump y 2 times, y, z, yeah, pumping 2 times, I'm pumping y one time here. So A, B, 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 and Z is BA. A4BA. So this also is in this language. Okay. So after pumping, the property of the language is not lost. This is the pumping theorem. Okay. So after pumping, if the property of the language is not lost, then the language is regular. That's it. Okay. You get me, huh? Yeah. Okay. So now shall we jump into the exercise? It's already 12:35. At least solve one problem. And I'll give you time to solve another problem. Here in the exercise, all the languages are not regular. Okay, let's take 4.2a. The language is A lengthen, B lengthen, C lengthen, where n is greater than or equal to 0. So how to solve this? How to solve this? So where is your xy? Okay, I will teach you a shortcut. L is equal to A lengthen, B lengthen, C lengthen, right? Where n is greater than or equal to 0. This is the language. Right? So I will immediately write let the string is equal to A length P, B length P, C length P, where P is greater than or equal to 0, right, is an element, that is this string is an element of the, okay, this can be written as xy length iz, where I is greater than or equal to 0, is an element of L, B regular. I am making an assumption. That is, I am taking a string as A length P, B length P, C length P, where P is greater than or equal to 0, can be written as xy length iz. That is, I am saying this string can be written as xyz, meaning I can split the string in terms of xyz. Okay, and this string is a member of this language. I am assuming it is regular. I am saying let be regular. Okay, it means let us assume the string is equal to A length P, B length P, C length P, where P is greater than or equal to 0, can be written as xy, same as xy length iz, same as can be written as xy length iz, where I is greater than or equal to 0, is a member of the given language, is a valid string in this language, be regular. So I am making an assumption. Okay, so what is the next step we need to do? If you do this in your exam, this will carry 1 mark. Because this question is 8 marks. Okay, after you write this assumption, the next step is immediately writing what is the value x can take, y can take, z can take. So when we do the splitting, assigning the value, because you are saying xyz is equal to xy is equal to A length P, B length P, C length P. So if you say this, you have to say what is the value x can take, what is the value y can take, what is the value c can take. Okay, if you still don't understand this, I will take you out to the Pasamalam and say I'm thinking of food for C. The carrot comes to the mind. The carrot is a vegetable. Sorry? Chiku or what is that? Lemon. I'm taking C. It's too less. Right? No need to. Chiku, we Indians call it as a sapota. Brown color, skin one. And it is a nice one, nice one. Okay? So what is being just 2 apples, 2 banana, 2 chiku. Okay, yeah? I'm saying X, Y, Z, huh? So meaning these fruits have to be split between X, Y, Z. Okay? So I can split something like this. X is equal to apple, banana. Y is equal to maybe 1 banana and 1 chiku. And Z is equal to maybe 1 apple. Banana already exhausted. Apple already exhausted. So I can divide. I can assign randomly. I want. Okay. And maybe some parents, what they do, my eldest child, I like more, so I give more fruit. You are very naughty, I give you no fruit. That is different. Okay? You understand splitting, eh? Assigning X, Y, Z. But here, by the lemma, we have to satisfy this condition when we split. X, Y, the number X, Y can take should be less than or equal to P, and Y cannot be given nothing. Okay? So where is your P? P is here. P is 2, right? In our example, P is 2. So X and Y together can take only 2 fruits. You get me? X and Y together can only two fruits. Here I have given X 2 fruits, Y. Here I am very rational. 6 fruits, 3 buggers. I have given each bugger 2 fruits. I am very rational. No bias, no partiality. But here, the splitting has to follow these 2 conditions. Y cannot be given nothing. Okay? When we say this, what is the value, in this example, what is the value maximum Y can take? In this condition, what is the value Y can take? Here, when I discussed, maybe you would have forgotten. What values Y can take is, Y can be greater than 0. Sorry. Y just says greater than 0. Sorry, that this condition is applies here. This condition is applied here. Yeah. So what value in this example? What is the maximum Y can take? Oh my God, so difficult. What is the value Y can take? We are saying xy is less than or equal to p. What is the maximum value Y can take? 2. X and Y together, maximum is only p. In this example, X and Y together is only 2. Right? Y cannot be equal to 0. It doesn't say X can take 0 or not. It can take 0. It doesn't say X cannot take 0. Okay? So maximum value Y can take is 2. What is the minimum value Y can take? 1. You understand? Yeah. So X and Y together can take only 2 fruits. So I have to recalibrate this division. So I have to say X and Y has to be 2. I can't say apple, banana because we have 3 different fruits here. Okay? I'll simply say X and Y can take only 2 fruits. Right? And Y cannot take 0 fruits. So it means X has to take 1 fruit and Y has to take 1 fruit. Whatever remains can be thrown to C. That's a zero. Okay? Understood that? Now coming back here. Where is your xy? Xy less than or equal to p, right? Your xy is here. Xy is less than or equal to p. Okay? You may say xy less than or equal to p, right? Then can I P is here, P is here, P is here. Can I take xy here? If you take xy here, where is your z? You get me? Z is lost. This whole thing is xy z. You shouldn't forget. Okay? So I cannot take xy here. I cannot take xy here also. If you take xy here, then you may assign this as z. This will be lost. Okay? So don't forget, this whole thing is xyz. Okay? This whole thing is xyz. Where xy should be less than or equal to p. So to me, your xy is here. Whatever remains, I can throw to z. So how to write it here? So xy is equal to p. So I'm going to divide p between x and y. So I'm going to divide this between x and y. That is, you can take p some value here. Let us take a bigger value, p is equal to 5. So what value x can take, y can take? I'm taking p as 5 now. So y can be 1. Correct, right? Correct, right? If I take 2, you get me? So y must take minimum 1. When y takes minimum 1, this will take the remaining 4. Correct, right? This is an example. But here p can go up to infinity. P can be any number. So I need to write here in general. So what I'm going to do is, I am going to take this 1 as k, and I'm going to take this 5 as my p. So it's going to be p minus k. So if k is 1, 5 minus 1 is 4. If k is 2, 5 minus 2 is 3. If k is 3, 5 minus 3 is 2. If k is 4, 5 minus 1 is 4. Okay? And if k is 5, 5 minus 5 is 0. You understand? So now k has a minimum value and maximum value. What is the minimum value k can take? K should be minimum 1, right? So k should be greater than 0, but less than or equal to p. K is 1, p is 5. You understand? I'm going to apply this theory here. So I'm just going to say my xy is here. So y is going to be a power k, a length k. Then I have to minus the k from p. Always remember this example, 5 minus 1, this is 1. Whatever remains, I simply throw to z. P length p, c length p, that's all. Now what we do? For this splitting, I give 4 marks. 4 marks. Because if your splitting is correct, your answer is going to be correct. The crux of the problem is here. Your splitting has to be correct because your splitting has to follow this lemma. Will the lemma be given? This is given? No. You have to remember. It's not difficult. Length of xy is less than or equal to p, length of y is greater than 0. That's all. This is your lemma. So this lemma theorem you have to remember. The two conditions you have to remember. Okay? So now what I'm going to do, I'm just going to say x, y, y, z. I don't need to say pumping y. You can say pumping y, no harm. But when I write x, y, y, z, I'm only saying pumping y, adding y one more time. Why? We already written here, this a length p, b length c, b length p, c length p is equal to x, y, z. We already have said this. Okay, this string is equal to x, y, z. So when I say x, y, y, z, I'm saying pumping y one time, adding y one time. Okay. Actually, if you combine this, what is x, y, z here? What is x? A length p minus k. Y is a length k, and your z is p length p, c length p. So this will be A length P minus K plus K, B length P, C length P. Minus K plus K will get cancelled. A length P, B length P, C length P. You are getting back your XYZ. Okay, yeah? So what we are doing is we are pumping Y one time. So when you pump Y one time, what happens? X is A length P minus K. Y is A length K. Y one more time. Repeat Y one more time. Then C is B length P, C length P. So this is same as A length P minus K plus K plus K. A length K, A length K. So I'm writing as A length P minus K plus K plus K. This plus K is here. This plus K is here. P length P, C length P. So what will happen? Minus K plus K will get cancelled. You get A length P plus K, B length P, C length P. So this is the resultant string. Right? The string you get as a result after pumping Y one time. So what is the resultant string now? Is it in this language?
No.
No. Why? You are going to have more A's than B's and C's. The number of A is going to be more than B and C. Because A is length of P plus K. And you already know K has to take a value minimum 1. Right? So you're going to have more A's than B's and C's. But what the language says, length of A, B and C are always equal. So I simply say is not an element of the given language. Therefore, the given language is not regular. So for this 4 mark, for this 2 marks, 6 marks, 1 mark, 7 mark, 1 mark for this 8 marks. Final exam. Test pumping number not there. So why not there means we are only learning now. Always happens. When we learn pumping number, mostly test will be over or test will happen the same week. Yes.
Can you go around the house more back again?
Sorry?
Can you go around the back and explain through this question again?
3 plus 4, 7 plus 1, 8. You will have 5 questions exam. Question paper is there in the My Times. There are a few exam papers with answers. Video also is there. You can go and check. So you can see the marks there. Okay. Of course, it won't show the split. It will simply say 8 marks. Okay. Because 5 questions, each question carry 16 marks. So 5 16 is 80. Why 80 means your final exam weightage is 40%. Okay, you can mark your attendance, please.